Hello everyone, my name is Kwon and I am a PhD student in the Human-Computer Interaction Institute at Carnegie Mellon University. I will be presenting our work in investigating demographics and motivation in engineering education using radio and phone-based educational technologies. Inequality in educational opportunities is a perpetual problem, preventing millions of people from receiving the education they deserve. While online educational systems, specifically MOOCs, aim to globally encourage social mobility and learning, prior research on MOOCs found that more advantaged learners in education and socioeconomic status are likely to benefit. This may be due to the numerous barriers that prevent underserved learners from participating in these systems, specifically for those in rural living contexts from low and middle income countries. These barriers include long and hazardous traveling distances to the nearest schools, lack of transportation, and expensive tuition. Education may also be deprioritized for many learners as the main source of income for many families in rural regions is subsistence farming, where there is a need for children labor. Furthermore, there is a disproportionate female attendance at schools due to pressure from women and girls to stay at home to fulfill household responsibilities. Hence, there is a need to investigate accessible alternative solutions that provide meaningful educational experiences to these remote learners. For instance, the uses of older technology in education are separately demonstrated in interactive radio instruction, known as IRI, as well as mobile phone-based interventions. It is also important to note that while the success of previous low-tech approaches, such as IRI and phone-based interventions, have been deemed successful, these approaches are non-reciprocal, in which students solely learn from delivered educational content. Additionally, while radio instruction provides the interactive aspect, interaction data is difficult to log, preventing an in-depth understanding of how demographics and other important features may influence learning. Hence, we studied an existing remote course launched in 2021 that delivers practical engineering education through radios and mobile keypad phones focused on learners within remote and rural contexts of Northern Uganda. Radios and mobile phones are the two most commonly used and possessed technologies in Ugandan households, not requiring internet connectivity and advanced technical skills to learn from the introduced virtual course. For this study, we analyzed log interaction data from this existing course in examining the association between the course and changes in learners' motivation to pursue occupations and learning opportunities in STEM, engineering-based mindset, course participation, and income mobility. We also investigated features that affect these changes in discussing learner outcomes in course completion and persistence, and performance on the final exam in relation to three main factors: initial motivation for participating in the course, various demographic features of learners, and their access to technology. The course curriculum followed the steps of the engineering design process, which is centralized on students creating an innovative product using locally available material by the end of the course. For this course, the final product students created was a solar cell, which is a device that converts sunlight into electricity. The course was delivered within a 15-week timeframe. Students are first given a baseline survey before accessing course content, which is accessed through USSD. An isomorphic endline survey is delivered at the end of the course. Students usually prepare for the broadcasted lesson they will listen to. Lesson instruction and content are delivered through radio broadcasts on certain days of the week, where students turn on their radio to the channel where instructors relay lesson content. In listening to radio content, students learn from the lesson material, follow instructions on creating the course's final product, and actively engage with weekly lesson material where instructors provide exercises, in which students respond via USSD with their mobile phones, including a phone-based weekly assessment on the previous week's course content. In the last week of the course, students complete a final exam, which is also delivered via radio broadcast. We used the McNeam-Rebecca symmetry test to measure the degree of significant movement response from the baseline to endline surveys to observe changes in student motivation, engineering-based mindset, income mobility, and outlook on pursuing future STEM education or related careers. To measure the impact of student demographic features on course completion, we conducted standard chi-square tests of independence to determine whether the proportions of students in a certain feature group who completed the baseline surveys were statistically different from the proportion of students in the endline survey, which is the last activity delivered to learners' phones. To find the predominant demographic and motivational features that influence student learning, we applied a linear regression model on student scores on the final assessment to measure the impact of each identified demographic and motivational feature on student exam performance. We initially identified approximately 18,000 registered learners, in which about 14,000 students completed the baseline survey. Approximately 4,000 students out of the 18,000 students made it to the end of the course, which is a rate of approximately 23%, which is double the less than 10% completion rate cited by previous MOOC studies. In providing a unique educational experience using low-ed tech, it is important to understand if learners benefited from participating in the course. Subsequently, we found encouraging changes in motivation, mindset, income, and opportunities in STEM for those who completed the course. Learners were more likely to say that the reason for taking the course is to learn science and technology over passing exams and making money. When asked about solving problems in their community, we found significant shifts in responses to try different solutions to achieve their goal rather than trying the same thing repeatedly. Furthermore, learners were more likely to definitely take a STEM course in the future and to possibly pursue a STEM-related career in the future. These students, in fact, showed a high performance on the final exam. In relation to previous MOOC studies, we show similar findings that support the positive association between intrinsic motivation and overall course performance. While some MOOC studies prioritize intrinsic motivation to learn, our study also emphasized income mobility as a significant outcome of student learning. Since subsistence farming is a major source of income for most participants, the dynamic seasonal nature of farming can lead to inconsistent income flow. Our work showcases another potential source of income with what students have learned and built throughout the course, on encouraging financial change. In fact, more learners stated that they earned income after the course. Income increased for learners who received income before and after the course, which is more likely to be from science projects than farming according to our analysis. In investigating influential demographic features on course persistence and performance, we found that learners who are in typically lower status positions were better able to take advantage of this course in their learning. While the course was delivered in English, those who preferred local languages completed the course at similar rates and performed similarly on the final exam of the course. Moreover, while fewer female-identifying students enrolled in the course, they completed the course at a higher rate than male-identifying students. However, students with children were less likely to enroll and complete the course. This may be due to women having children at a younger age, which requires them to be primary caregivers for their children and hence, a deprioritization of their education. This is an important finding in understanding gender and family background in similar educational contexts. While it is natural to expect that urban residents are receivers of higher educational opportunities, our study showed urbanicity to be an influential demographic on course learning and completion, in which learners who live in villages were most likely to complete the course at a higher rate and score just as well on the final exam, implying that access to city resources was not necessary for this virtual classroom. Another feature we investigated is access to technology, specifically access to internet and radios. A significant difference between this remote course and MOOCs is the lack of requirement for internet access. While access to internet may imply other life advantages, our study shows that learners with no internet access completed the course at a higher rate and performed equally as well on the final exam as those with internet access. However, surprisingly enough, access to radio had no significant association with course completion and performance. This may be due to a number of reasons. The first is that listening to the radio broadcast is technically not required to answer lessons and survey questions as they are delivered through SMS. Another reason is that community centers in low infrastructure settings are common as learners can share communal radios and phones. This finding shows that there is a need to further investigate the context of radio use in these learning contexts. We also found that unemployed learners perform higher on the final exam. An encouraging finding is previous MOOC studies stated that many participants are from employment that requires higher education. However, remaining disparities still remain as our findings align with previous MOOC literature that shows that learners with prior educational experience, especially those with secondary and higher education, are more likely to show higher learning performance. In fact, each year of educational experience is associated with a lower final exam score. Moreover, those with the highest level of education were more likely to drop out of the course. These findings imply that basic education needs further investigation for similar learning systems trying to reach out-of-reach learners. While MOOCs claim to democratize education of all learners, current educational inequalities show that this may not be the case. Our study introduces a global alternative that provides unique learning benefits for underrepresented populations, as we found that most learners with no internet access, non-English language preferences, and demographics related to lower status positions generally completed the course at higher rates and performed equally as well in the final assessment. Our study introduces a combined interactive remote learning system that uses both radios and phones, in which students have the opportunity to learn from a well-rounded curriculum with test questions, real-time lesson content, and creative activities in building a final innovative product, while student interaction data is synchronously logged, allowing for investigations on connections between important demographic and motivation features on student learning.